Hello everyone. Today we will discuss about the power in an AC circuit. So we know that if we can derive it for LCR circuit, we can find it separately for resistor, inductor and capacitor if we know the phase difference between the current and the voltage. So I find this method easy, that first derive the expression for series LCR and then put the phase difference values for resistor, capacitor and the inductor separately as the case may be. Otherwise, you can directly put the expressions for voltage and current for resistor case, for inductor case, for capacitor case, and then you can apply trigonometry to find the result separately also, that way also. But I find it simple because you find first for LCR and then write the phase difference and put the values and get the answer. Okay? So that's why we have taken here series LCR circuits. So we know that the power is given by the formula VI, right? So VI, or here we are writing the voltage by EI. So what will we do? We are talking about LCR circuit. If we say that VOL is greater than VOC, that means we can say if the inductor is dominant, then we will see that the voltage will lead. So if I am writing the expression then voltage will lead. So this is E naught sin omega t. I can write for I naught sin omega t minus phi. We know that this is not a pure inductor, that's why the phase difference between current and voltage is not pi by 2. There will be phase difference, but how much, it depends on the values of the voltages and the voltages across inductor and capacitor. So phi is the phase difference. We can write this. So multiply and divide this by 2. What will we get? If we consider this angle as A and this angle as B, then we know that 2 sin A sin B is equal to cos A minus B minus cos A plus B. So power will be E naught I naught upon 2, and this will be cos of A is omega t minus B is omega t minus phi. Minus cos A plus B means omega t plus omega t minus phi. Let's solve it. This will be cos of minus phi minus cos of 2 omega t minus phi. Cos of minus theta is cos theta. So we can write down this like this. And this is time dependent quantity. This is a cost function of time dependent quantity whose average value for complete cycle is 0. So if we are finding this average power for the complete cycle, then this value will be 0. So we can write down cos 2 omega t minus phi is equal to time dependent cos function for complete cycle is equal to 0. Okay, so that's why I have placed it 0. Now what will be my formula? This will be E naught upon root 2. This can be written like this, and this can be written as I naught upon root 2 and cos phi, and this can be written as P average is equal to, is it visible? This is E RMS I RMS into cos of phi, and this can also be written in the other form, E is equal to IR, so I can write it I RMS square into R into cos of phi, or this can also be written as E RMS square upon R into cos phi, where cos phi is called as power factor and it is the ratio of real power upon apparent power. So this can be written as I naught R upon I naught Z, and this will be R upon Z, right? So this is about power in a series LCR circuit. So this is our standard formula. Let's mark this as equation 1. I told you, I am telling you the simpler way of finding the average power in a resistor, inductor and capacitor. So in the last step, we will put the phase difference value there, then we will get power across a resistor. So this will be for resistor, phase difference between the voltage and current. So your power average formula will be ERMS IRMS cos of 0 degree. So this gives me ERMS IRMS, and this can also be written in other forms like this, ERMS square upon R, and this can also be written as IRMS square into R. Similarly, that means the maximum power is consumed or dissipated in a resistor. So maximum power is dissipated in a resistor. Now comes your third case, power in an inductor, right? So for inductor, phase difference is pi by 2, but in case of inductor we know that voltage leads the current, right? But the phase difference is pi by 2, pi by 2, right? So you will write it here, power average is ERMS IRMS cos of pi by 2, right? I'll mention it here. Put right. So cos pi by 2 is 0. So this gives me 0. So power in an inductor is 0. That means pure if it has no resistance. Okay. So fourth is power in a capacitor when AC is applied to it. So for this, for a capacitor, phi is equal to pi by 2, but here current leads the voltage. Right? So here put this in. You will get it. Power average is equal to ERMS, IRMS cos of pi by 2, and this gives me 0. So therefore, power average in a capacitor is also 0. Right? So that's why pure inductor and pure capacitor are called wattless circuits, and current through these is called wattless current. Why wattless? Because watt is the SI unit of power. If power is 0, then we can say watt is 0. So that means wattless current and wattless circuit. So this was all about power in an AC circuit. Hope you understood all the derivations. This is a shorter one which I have done. So that's all for now. Have a great day.